This is Honors Geometry Lesson 1.6 Polygons. Let's try a couple practice problems. In number 15, it says the lengths in inches of two sides of a regular pentagon. Regular, we remember, means it's equiangular and equilateral. So we can assume all the sides have the same lengths, all the angles have the same measure. Are represented by the expression 5x minus 27 and 2x minus 6. So let's go ahead and set them equal to each other. 3x, add 27 to both sides, looks like 21, looks like x is going to be 7. And then to answer their question, find the length of a side, choose either one. I'm going to choose the easier. I'm going to go ahead and put that 7 in there. Looks like the length of the side is going to be 8 inches. Number 16 says the expressions 9x plus 5 and 11x minus 25 are represents the measure of two angles of a regular nonagon. Again, there it is, regular. So we're going to set those two equal to each other. Let's make some room here. So we're going to say that 11x minus 25 equals 9x plus 5. So we get 2x and add 25 to both sides. Did I copy that right? Yep, equals 30. It looks like x is going to be 15. And then we're going to substitute that back in. I'll say 9 times 15 plus 5. 9 times 15, let's see what that is. That looks like 135 plus 5. It looks like each of those angles would be 140 degrees. Let's jump down to the next section. Tell whether the statement is always, sometimes, or never true. A triangle is convex, which means it's not concave. If you look at a triangle, there's no way it can cave in. So we're going to say that's always true. It has to be convex, it can't be concave. A decagon is regular. A decagon can be regular, but it's not always going to be regular. So we'll say it's sometimes regular. A regular polygon is equiangular. By definition, that's what regular means. It's equiangular and it's equilateral. So we're going to say that's always true. A circle is a polygon. Remember, in order to be a polygon, you can't have a curved surface. So we're going to say that one is never true. A polygon is a plane figure. If you remember, that's part of the definition. So that's going to always be true. It means it's flat. It's two-dimensional. And the last one, a concave polygon is regular. If you remember the definition of a regular polygon, it's a convex polygon. If it caves in, it messes up the regular part. So that one's going to be never true. A concave polygon can't be regular. Let's check the next section. They want us to draw these figures. It's a triangle that's not regular. So we're going to make sure that the sides or the angles aren't all the same. So I'm just going to draw a tall, skinny triangle, and that's obviously not regular. Number 25, it's a concave quadrilateral. So it has to have 4 sides and it has to cave in. So I'm just going to do, oops, that's not a very good one. Let's try that again. We're going to make sure it caves in and it has 4 sides. Here we go. 1, 2, 3, 4. Okay. Last section, it says each figure is a regular pentagon. So that means we can set the sides equal to each other. Expressions are given for two side lengths. Find the value of x. So we only have to find x in this case. So we're going to set them equal to each other. Looks like we're going to luck out. Those x squares are going to cancel out. So we get x equals 4, and that's all we need in this case. So we don't have to substitute it back in. Let's try one more. We're going to say that x squared plus 3x equals x squared plus x plus 2. Again, it looks like our x squareds are going to cancel out. It's going to make our work a little bit easier. So we get 3x equals x plus 2. Subtract 1x from each side. Divide each side by 2. We get x equals 1, and we're done. Go ahead and try the practice problems. Let me know if you have any questions. Thank you.